On the basis of the power source used, arc welding can be classified as DC arc welding and AC arc welding. Let's first discuss about DC arc welding. Consider the arc welding setup with the DC power source. Now let's use this setup to weld 2 thick plates and then 2 thin plates. First, let us weld 2 thick plates. To weld 2 thick plates, we need to produce more heat at the arc. For this, make the plates as anode and the electrode as cathode. This generates a large amount of heat, which melts the edges of the plates and thus joins the plates. The weld bead formed by this type of welding would be: this setting of DC power source is called the straight polarity or DCEN, that is direct current electrode negative. Now let us weld 2 thin metal plates. In order to weld thin plates, we will make the plates as cathode and the electrode as anode. Now when we bring the welding electrode near the edges of the plates, we see that the heat generation is less and the penetration is small. This yields the welding of thin plates. The weld bead formed by this type of welding would be: this setting of DC power source is called the reverse polarity or DCEP, that is direct current electrode positive. Now let us discuss about AC arc welding. Consider the same setup as used in DC arc welding, but replace the DC power source with the AC power source, which is a step-down transformer. Now let's use this setup to weld 2 thick plates. First, bring the electrode near the interface of the plates and then press the trigger. We see that as we move the electrode, the arc is not stable and has a uniform temperature throughout. Thus the heat gets distributed over the metal plates. As a result, the weld obtained is little bit spattered compared to the weld in DC arc welding. Also, the weld bead produced is somewhere between the 2 types of weld beads produced by the DC arc welding Thus, DC and AC arc welding are methods of welding metals using the heat generated by an electric arc. The electric arc is produced from a power source, which can be AC power source or DC power source, respectively. Now let us list the merits of DC arc welding. In DC arc welding, majority of heat gets concentrated at the metal surface or tip of the electrode, thus making less spatter. In it, a stable arc is produced, and a desired heat distribution is also produced inside the arc. And it is used under both the conditions, that is, when deep penetration is required for thick plates and when shallow penetration is required for thin plates. And now, let us list the merits of AC arc welding. It is cheaper because we don't need any rectifier to change the current from alternating to direct. And in it, no arc blow is associated. The related term is